day 2 of our saga, and today we are going to talk about graphing. I know you're all very excited about this because I know how much you love to graph. Okay, so we're going to start off with a growth function, as you can see here, because our b is greater than 1. Our a is 1, so we're just not going to write it. So when we're graphing this, as always, when you think of graph, think make a table. So we're going to make a table of values, choosing -2, -1, 0, 1, and 2 for our x values. Okay, so now the difference here is that our x is in the exponent. So now we're going to be using all those exponential properties that we have talked about the last 4 sections. Okay? So here, if we put -2 in for x, we are going to get 2 to the -2nd power. Using our negative exponent property, remember this negative doesn't mean that the number takes on a negative sign, but this negative means reciprocal. Okay, so when we take a reciprocal of it, i.e. put it in the denominator, or if it's negative here, put it in the numerator, we're going to have 1 over 2 squared, because now since we took the reciprocal, that exponent becomes positive. Okay, and 2 squared is 4, so we get 1/4. Alright, if we put in -1 in our exponent, we again take the reciprocal, which is 1 over 2 to the 1, and 2 to the first power is 2, so we get 1/2. When we put 0 in for x, we get 2 to the 0 power. Anything to the 0 power is 1, so we have the point 0, 1. For x equals 1, we have 2 to the first power, which is 2. And when we put 2 in for x, 2 squared is 4. Okay, come on over here to graph. We have -2, 1/4. You see right here, 1/2, 1/4. Okay, these are labeled by 1s. So we're at -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. Okay, then we're going to draw this curve, and as you see going from left to right, we are getting bigger, so this is growth. But notice here that we have something called an asymptote. Okay, an asymptote is a line that a function approaches but never touches. Okay, and it's never going to intersect it either. If it doesn't touch, it's not going to intersect. Okay, so when we come up right here, you see that we're getting closer to the line, but if this graph were to go on forever, it would never cross and it would never touch x equals 0. Or y equals 0, excuse me. It's never going to touch this x-axis. Okay, because we're never going to get negative with this exponential growth function. Okay, so that's called an asymptote. When we identify our domain and range, our domain is anything. We can plug in any x value and get a corresponding y value. It doesn't matter if our x is negative or not. If it's negative, we're going to get a fraction. It'll be a very, very small fraction the further we get down. And if we put in a positive number, we're going to get a really, really big number. So x, our domain, is all real numbers, because x can be whatever it wants. Our y, because we have this asymptote, we're never going to get any negative y values. Okay, our graph, see this curve? It's never going to go below the x-axis, which below the x-axis is where our y's are negative. So here, our y values are only going to be on the positive. This is our y-axis. Okay, we're only using these y values. Okay, that's the only part where our graph shows up. So that means, since we can't be at 0, that our range is going to be y is greater than 0. Okay? Alright. Here, looking at a decay function, we have an a that's different now. It's 3, it's not 1. And a decay function, because we have a b that is less than 1 but greater than 0. We have a positive fraction. Okay? When we put -2 in for x, alright, that's going to give us 3 times 1/2 to the -2. Again, this means the reciprocal. This exponent belongs to this only. It does not belong to the 3. Okay, so we are going to take the reciprocal, the squared reciprocal of 1/2. Okay, so if we take the reciprocal of 1/2, We flip numerator and denominator, so we get 2 over 1. And now this becomes a positive exponent because we have done the reciprocal part. So now we have 3 times 2 over 1 squared. This squared still only belongs to the 2. 2 squared is 4. Okay, if you square your numerator and your denominator, you would get 2 squared over 1 squared, which 1 squared is 1. So 2 squared over 1 is 4, which we have here. And then we multiply. So 4 times 3 is 12. Okay, we want to follow order of operations. Order of operations says exponents first, then multiplication. So if you were to multiply the 3 times 1/2 first and then take the negative 2 power, that would be wrong. Okay, so you want to take exponent first, then multiply. Okay, if we put negative 1 in for x, okay, 3 times 1/2 to the negative 1, again, this exponent belongs to that fraction only. So we're going to take the reciprocal, which 1/2, the reciprocal is 2, 2 over 1. 2 to the first power is 2, times 3 is 6. When we put in 0, we get 0, 3 times 1/2 to the 0 power. So 1/2 to the 0 power is 1. 3 times 1 is 3, which this being our y-intercept, that is our a, so it checks out. Good. When we put in 1, 1/2 to the first power is in fact 1/2. Times 3, we get 3/2, or for my decimal friends, 1.5. Same thing. And then if we put in 2 for x, we get 1/2 squared, again using our power of a quotient property. That is going to be 1 squared over 2 squared, which is 1/4, times the 3. 3 over 1 times 1 over 4, multiply numerators. 3 times 1 is 3. 1 times 4 is 4. Alright, so we come over here and graph. We are at negative 2, 12. Negative 1, 6. Is that 6? 1, 2, 3, 4, 5, 6. Ooh. Struggle. 1, 2, 3, 4, 5, 6. Okay, and then we go to 0, 3, and then 1, 1.5, and 2, 3/4, or 0.75, whichever way you look at it. Okay, going from left to right, we are going down, so we do have this decay. Alright, again, we have this asymptote. We are going to approach this line, but never actually reach it, so that is called an asymptote, which means that our y values are going to be restricted again. Again, x can be anything, so we have all real numbers, which is for our domain, and then our range is going to be y is greater than 0, because again, we are using only that part of the graph with our function. Okay? Alright. Now we are going to compare graphs. Okay, so when we compare graphs, here I took our first example, which if you remember from our growth problem was y equals 2x. I already have it plotted. But we're going to compare y equals 3 times 2 to the x power and y equals negative 3 times 2 to the x power. So we want to see how the negative makes a difference. Okay? So we're going to go through the process the same way that we have the last couple of problems. Here, if we put negative 2 in, we're going to have 3 times 2 to the negative 2 power. Okay, that means we're going to take a reciprocal of the 2, which means that we're going to have 3 times 1/2 squared. Okay, reciprocal of 2 over 1 is 1/2. 1/2 squared is going to be 3 times 1 squared is 1, 2 squared is 4. Okay, and 3 times 1/4 is 3/4. Okay. Over here, if we were to put negative 2 in for x, we're going to have negative 3 times 2 to the negative 2. Same process, this means reciprocal. So we're going to have negative 3 times 1/2 squared. 1/2 squared is 1/4. Oops, that's a times. 1/4. And negative 3 times 1/4 is going to give us negative 3/4. Okay? I'm going to alternate colors so we just don't get confused from line to line. Okay, if we plug in negative 1, we're going to have 3 times 2 to the negative 1. Okay, again, we're taking the reciprocal of what's in the parentheses. So we're going to have 3 times reciprocal of 2 is 1/2 to the first power. Anything to the first power is itself. So we're going to have 3 times 1/2, which is 3/2. Okay, over here, we're going to have negative 3 times 2 to the negative 1. Take the reciprocal of what's in the parentheses, because this belongs to the parentheses only, not the negative 3. Reciprocal of 2 is 1/2 to the first power, which is going to give us negative 3 times 1/2. So we get negative 3/2. Okay. Alright, 0. Here we go. 3 times 2 to the 0. Anything to the 0 power is 1. So we get 3 times 1, which is 3. Here we have negative 3 times 2 to the 0. Are you noticing a pattern yet? I really hope so. Anything to the 0 power is 1. Oops, that's negative 3. Negative 3 times 1 is negative 3. I really hope you're noticing the pattern. Here to here, here to here, here to here. What's the difference from here to here? That little guy. Oh my word. Okay. 3, we put in 1 for x. 2 to the first power is in fact 2, which gives us 6. Should be an equal sign here. And here we have negative 3 times 2 to the 1, which is negative 3 times 2, which is negative 6. And last but not least, if we plug in 2 for x, we're going to have 3 times 2 squared. 2 squared is 4, which gives us 12. Here we have negative 3 times 2 squared. 2 squared is in fact still 4, but 4 times negative 3 gives us negative 12. Alright, let's graph. Let's do blue for this guy, and then we'll do green for this guy. Okay? Alright. So I have the point negative 2, 3/4. So negative 2, 3/4, about right here. Then I have negative 1, 3/2, which is about right there. 0, 3. 1, go over 1, up 6, 1, 2, 3, 4, 5, 6. And 2, 12. Right here. So this guy we are going to approach but never touch our asymptote. Okay, so comparing just those two graphs, so comparing our 3 to the 2x and 2x, what has happened to the graph? Okay, I know a lot of you might think in terms of slope. We cannot say slope here because it's an exponential graph, so it's not a constant rate like slope is. But here we do get a steeper curve. Because this 3 is greater than 1, it is going to steepen the curve of the exponential growth, and it's going to grow faster because that number is bigger than 1. So it's going to get to bigger points quicker than the actual original graph, which is 2 to the x. Okay? And then if we plot the last one, we have negative 2, negative 3/4, negative 1, negative 3/2, 0, negative 3. 1, -6, and 2, -12. Approach the asymptote, but never touch. Okay. How does this graph compare? Let's compare it to this graph. Okay, first of all, if we're comparing these two graphs, we have a reflection. This is a reflection over the x-axis. Our x's stay the same, but our y's are opposite. So we have just flipped this graph over the x-axis, and there you have it. Okay? If this graph is the blue one, but just flipped over, then we can also say that this graph is steeper than this one. Okay, because it's going to have the same steepness as the blue graph, but it's just going to be flipped over, so it's still going down. Okay? Alright, and for watching the video, I will give you an opportunity for extra credits. And here's what I want you to think about. How do you think the graph y equals 1/3 times 2 to the x compares to y equals 2 to the x? Okay, so here was y equals 2 to the x. We noticed that 3 out front here, if our a was 3, we did get steeper. How do you think y equals 1/3 times 2 to the x will compare? Alright, if you want the extra credit, comment on the video. I will be checking this at 9 p.m. the day that this video is assigned. So make sure that your comments are in by then, and I will see you in class.